Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Now we want to show that ddx x to the n minus 1 times square root 4 minus x squared equals to this, and let in equals to this, and prove that nin equals to 4 times n minus 1 in minus 2 minus root 3. Given that I naught equals to pi over 6, we want to find I4, and we want to leave our answer in the exact form. So without further ado, let us do the differentiation. So differentiate x to the power of n minus 1 times square root 4 minus x squared. We have x to the n minus 1 d dx square root 4 minus x squared plus square root 4 minus x squared d dx x to the n minus 1, which then simplifies to x to the n minus 1 times 1 over 2 times 1 over 4 minus x squared times negative 2x plus square root 4 minus x squared times n minus 1 times x to the n minus 2. And the rest is just simplifying the whole equation to match the identity. Furthermore, you need only cancel out the term square root 4 minus x squared to achieve the required result. So the next part, we integrate the relationship we have already proven. Integrate from 0 to 1 d dx x to the n minus 1 square root 4 minus x squared dx equals to integrate 0 to 1 4 times n minus 1 times x to the n minus 2 over the square root of 4 minus x squared dx minus integrate 0 to 1 n times x to the n over square root of 4 minus x squared dx. So on the left hand side, integrate and differentiate cancels out. We have x to the n minus 1 square root 4 minus x squared with the boundaries 0 to 1, and equals to 4 times n minus 1 integrate x to the n minus 2 over square root 4 minus x squared dx minus n integrate x to the n over square root 4 minus x squared dx. And so root 3 equals to 4 times n minus 1 times in minus 2, because we have x to the n minus 2, and minus n in, because the second one is x to the n. And rearranging it, we have n equals to 4 times n minus 1 times in minus 2 minus square root of 3. I will just only show you until the reduction formula part. The rest of the question is just substituting and will be left to you. Next, the centroid of an object is such a point that it is the average or arithmetic mean of all the points in the object. Say an object consists of n numbers of points, and xi is the distance of the point from some reference point in the x-axis. Then the distance of x coordinate of the centroid of the object from the reference point is given by cx equals to x1 plus x2 plus x3 ... until xn, and divide by n. This can obviously be extended to any numbers of finite dimension. If you have completed the M2 unit of the CIE A-Level Mathematics course, you might surmise some similitude centroids have with centers of mass. Assuming uniform density, an object has the same point for its centroid and center of mass. You will not be questioned about this in the pure paper, but for the applied paper, we will study this topic in greater detail in the future. The formula relevant to the pure paper are as follows. For a curve y equals to fx, defined between a is smaller than x and x is smaller than b, the x and y coordinates of the centroid is given by cx equals to integrate a to b x times y dx over integrate a to b y dx, whereas cy equals to 1 over 2 integrate a to b y squared dx over integrate a to b y dx. So let us take a look at an example of how to use this formula. So we want to find the coordinates of the centroid of the curve y equals to square root 1 minus x, for x is between 0 and 1. So integrate from 0 to 1 y dx equals to integrate from 0 to 1 1 minus x to the 1 over 2 dx, which is a straightforward integral. So we have negative 2 over 3 times 1 minus x to the 3 over 2, which equals to 2 over 3. We also note that integrate from 0 to 1 x times y dx equals to integrate from 0 to 1 x times 1 minus x to the 1 over 2 dx. And we sub u equals to 1 minus x, and we have integrate from 0 to 1 negative 1 minus u times u to the 1 over 2 du. And simplifying the integral, we will obtain 4 over 15 as our answer. Hence, cx is 4 over 15 over 2 over 3, which equals to 2 over 5. Now we also want to compute cy, but before that we need to know the integral of y squared, which equals to 1 over 2. So cy equals to 1 over 2 times 1 over 2 over 2 over 3, which equals to 3 over 8. Now let us look at how to find the mean value of a function. For a function y equals to fx, defined on a range x between a and b, the mean value of the function is given by y bar equals to 1 over b minus a integrate from 0 to 1 y dx. Let us look at this example. The curve has, for x between 0 and 4, the equation y equals to 2 times x to the 1 over 2. So let us first find the mean value of y with respect to x by substituting the formula. So y bar equals to 1 over b minus a times the integral of y dx. So b minus a is 4, so 1 over 4 integrate 2x to the 1 over 2 dx. And substituting the boundaries, we will obtain 8 over 3. And it also asks us about the y-coordinate of the centroid. So we will find the integral of y and the integral of y squared. So the integral of y equals to 32 over 3 and the integral of y squared equals to 32. So the y-coordinate is then simply 1 over 2 times 32 times 3 over 32, which equals to 3 over 2. The arc length of a curve defined in rectangular, parametric, or polar equation is found by the application of the following formula, provided the function is differentiable over the given range. So in the first case, for the function y equals to fx, for the region of x between a and b, s, the arc length, equals to the integral of a to b, and the square root of 1 plus dy dx squared dx. And in the second scenario, for the function x equals to fy, which is the inverse of the function above, and defined for y between c and d, the arc length s equals to integrate c to d, the square root of 1 plus dx dy squared dy. And for the third case, which is the function defined parametrically, y equals to ft and x equals to ft, for the region where t is between e and f, then s equals to integrate from e to f the square root of dy dt squared plus dx dt squared dt. And finally, the fourth one is for the polar function defined by r equals to f theta, where theta is between g and h. So in this case, s equals to integrate from g to h the square root of r squared plus dr d theta squared d theta. So you just have to memorize all of this formula. Now for the area of surface of revolution, the first case, for the function y equals to fx, defined for x between a and b, is rotated through 2 pi about the x-axis. The area of the surface formed is given by this formula, where surface area equals to integrate a to b 2 pi y square root of 1 plus dy dx squared dx. And for the function x equals to fy, defined by y between c and d, rotated through 2 pi about the y-axis, the surface area is given by this formula. Integrate between c and d, and then 2 pi x square root of 1 plus dx dy squared dy. And finally, for the function defined parametrically, y equals to ft and x equals to gt, defined where t is between e and f, the area of the surface generated is given by this formula, where you integrate from c to d 2 pi y square root of dy dt squared plus dx dt squared dt. By replacing y with x in the formula above, you get the formula for the parametric analog of the function generated by rotating about the x-axis. And now we look at an example where we can apply the formula above. So we have the curve C with the parametric equation x equals to 1 over 3 t cubed minus ln t, and y equals to 4 over 3 t to the power of 3 over 2. And the t is in between 1 and 3. It wants us to find the arc length and also the surface area generated when c is rotated by 2 pi radians about the x-axis. So you have to try the arc length yourself, and I'm going to show you how to find the surface area. They are more or less the same, but the surface is harder. We first find the derivative with respect to t first. So dx dt, or x dot, equals to t squared minus 1 over t, or t cubed minus 1 over t. Then dy dt equals to 2t to the 1 over 2. Then we compute for x dot squared, which is t to the 9 minus 2t cubed plus 1 over t squared. And y dot squared equals to 4t. Performing the root extraction of the sum of the two squares of the derivative, we have square root of x dot squared plus y dot squared equals to square root of t to the 9 minus 2t cubed plus 1 over t squared plus 4t, making it into a single fraction, which is the square root of t to the 9 plus 2t cubed plus 1 over t squared. And then we factorize the numerator, we got t cubed plus 1 squared over t squared. And now we have both squared on the numerator and the denominator, and the square root can be cancelled out, which simplifies to t squared plus 1 over t. Now we need only to integrate this result. So for the area of the surface, we have this formula: integrate from a to b 2 pi y square root of dy dt squared plus dx dt squared dt. And we have already evaluated the square root of dy dt squared plus dx dt squared. So we have therefore 2 pi integrate from 1 to 3 y times t squared plus 1 over t dt, where y equals to 4 over 3 times t to the 3 over 2. So after simplifying it, we have 8 pi over 3 integrate from 1 to 3 t to the 7 over 2 plus t to the 1 over 2 dt. And the integral is simple enough, so we have t to the 9 over 2 divided by 9 over 2 plus t to the 3 over 2 divided by 3 over 2. And then we substitute in the boundaries and we obtain the final answer, which is 282.76.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.